closed. Talking piecewise functions. What's a piecewise function again? Remind me, what are we talking about here? What's different about a piecewise function than every other function you've ever talked about?
Made up of two or more.
Yeah, okay, it's made up of at least two, maybe more parts. And we know which part, if an ant's walking along this function, the piece he's walking on is determined by the input value, the x value, right? So each part, each piece of a piecewise function gets its own domain. And we were looking at, we evaluated yesterday, you know, if we wanted to plug in an x value, we have to first figure out which piece the x value is going to apply to, and then, you know, we plug it into that equation. We started graphing piecewise functions, and I want to pick up there. So what about one like this? How am I going to approach graphing this piecewise function? What do we do? Okay, we got to split it into the three sections. Yeah, absolutely. Now, where are the dividers going to be? The vertical lines that are going to divide this 0 and 6. Yeah, there you go. 0 is one of the x values where we transition between pieces, and 6 is one of the values. Okay, so we got our three pieces. Let's graph the first one. Let's graph the red piece. How am I going to graph the red piece? Say it again. The x value is by -3. Good. And before we go any further, like, look at all three of these. I mean, later on in life, these won't have to be such simple equations, but everybody agree those are just all linear equations. Those are all equations that fit the form y = mx plus b, right? So they're all linear. If I want to graph a linear equation, how do I always graph a linear equation? Because I'm going to get a line, right? Linear gives us lines. How do I graph a line? Need 2 points, right? I just need 2 points, and then I connect and extend. Okay, well, how am I going to get my 2 points for the red piece? Hold that thought for just a quick second. Okay, so back to business here. Sorry about that. So what am I doing again? How do I get my 2 points for the red? What I've got, you know, the top piece, which we're kind of color coding red here. How do I get my 2 points? What do you think? Okay, so how come 0? That's a great choice. Why do we want to pick 0 as one of our points? Okay, yeah, it's on the border. It's on the boundary, right? We always want to have 1 at the border so we know when I graph this line, we know where it ends. That's an important point, right? As we move forward in math, a lot of times we don't really need to do graphs. Graphs are exact, are sort of exact representations of functions where every point is exactly in the right spot. When we graph stuff in math, I mean, I know you used to do this. You know, we used to graph on graph paper with pens and pencils, but how do we graph stuff now in the modern age? From this point forward, how do you graph things in math? We're not going to do it on paper because it's never going to be exact on paper. What do? Either a graphing calculator or Desmos is a graphing calculator. Typically for us, it'll be on Desmos graphing. So if we actually need a graph to work with, we're going to use technology to do it. Most of the time we don't. Most of the time we just need a sketch. Like in calculus, we seldom ever do a graph. We just want to have a basic representation of the function where some of the really important points are exact, but the rest of it we don't care about so much. You know, what are the important points? Things like intercepts, where functions cross the axes. If it's a curve, we want to know where it has a minimum or where it has a maximum. Those are important points. Where functions intersect. In this case, the most important points are going to be the places where the lines end up when they get to a boundary, right? So we want to have that point for sure. So we're going to input the value x = 0, and if I plug in x = 0, what's the output? What's the y value for the red piece? Yeah, absolutely, it's 0. So we got the point 0, 0. Is that going to be open or closed? Open. How come? Not included, right? 0 is not a part of the red domain. It's a part of the blue domain. Okay, so then we're going to have to put an open endpoint up here at 0, 0. And then now you get a little bit of a choice. What are some options for another point to draw that red line? -1, -2, whatever. We want to pick one. -10 probably wouldn't be a great choice. How come? Yeah, it's too big, isn't it? Then I'd end up with 30, which is off of my graph. That's no good. But I could pick something like -2, for example. If I plug in -2, I get +6, and so -2, let's see, 1, 2, 3, 4, 5, 6, right there. And then now all I have to do is just, connect and extend, and we got it. So something like that. Okay. What about the blue? What would be the two values we'd want to use for our blue points? 0 and 6, absolutely. If I plug in 0, what do I get? -1. 0 gives me -1. What if I plug in 6? -4, I agree. Okay. And what can you tell me about what kinds of points I need there? First one is closed, second one is open, all right. 0, -1, 2, -4. Or sorry, 6, -4. There. Okay, there's that piece. And then finally, green one, first point I want to pick, 6. What do I get if I plug in 6? -1. And then probably something like, 7 or 8. Would we pick 8? And we got it. Okay, so, oops, I guess I don't go back. -6, -1, so right there. Something like that, right? Okay, so now what about the domain? Is it all reals? You sure? Here, I want to, this is probably hard to see. Keep in mind, yeah, there's a missing x value, isn't there? Right? If I project all of those graphs onto the x-axis, it's going to graph the entire x-axis, but there's no, there's no defined point at x equals 6, right? I have open endpoints for both of those pieces, and so the projection would just look like this, wouldn't it? It's going to go all the way up to there, but we're going to get an open endpoint. And so how would I say that? A couple ways I could say that. One way I could say it is, and this is honestly probably the best way, it's just x does not equal 6. Right? What is that telling us? If I specify x does not equal 6, then that just implies that every other real number works. If I used interval notation, how would I have to write that? It's a little bit inconvenient. How many intervals, let me ask you this, how many intervals are contained in that purple projection of the domain? How many intervals though? And what do I mean by an interval, right? Let's remind ourselves, when we're graphing an interval on like a number line, intervals are the number of times I have to pick my pen off the board, right? Like if I could just put my pen down on the previous example we did yesterday, the domain was all reals. I could just put my pen down at -infinity and keep it on the board the entire time. I never have to pick it off the board, right? How about this time though? If I put my pen on the board at -infinity and I'm graphing the domain, what happens when I get here? I have to pick it off the board for 1 pixel, call it, right? Then put it back down. and continue on to positive infinity. It's interrupted, right? What we'll come to say is that this is eventually, when we talk a lot about this kind of thing in calculus, we'll say it's discontinuous. There's a discontinuity in that domain at x equals 6, right? So again, how many intervals are there? How many purple intervals? There's 2, yeah. One to the left of that interruption and one to the right. So when I use interval notation, I have to write 2 separate intervals. What's the first interval going to look like? Negative infinity up to 6 with a, good. And then if I'm using interval notation, what do I have to put in the middle? Yeah, it's got to be an or statement, doesn't it? Because the ant is either going to be standing on the left interval or the right interval, right? Or, and then the right one would just be what? Yeah, 6 to infinity, right? Okay, give me thumbs. Does that make sense? Okay. How about the range? If I project all this onto the y-axis, what do you find? We can just do it one at a time, I guess. So if I project the red piece onto the y-axis, where does it start? 0, and then just goes up to infinity. 0 is not included though, right? Okay, so the red piece would project like that. What about the blue piece? Where do the y values are going to go from where to where? -1 to, I guess, what is that, -4? I'm going to get a closed endpoint and an open endpoint. And then finally, what about the green one? From -1 up. So then what it's going to do is it's going to fill in that point on its way up, right? Everybody see that? So that's what we're left with. So what is the range then? There's the projection onto the y-axis of all 3 pieces. What do we end up with? As an inequality, what? Y is greater than -4? How many intervals are there in the range? Just 1, yeah. Right, so it's just going to look like -4 to infinity if I turn my head sideways and look along the y-axis, okay? Give me thumbs on that. Does that make sense? Okay, all right, we're getting this. Okay, let's work the other way. This time I gave you the graph, and now we've got to use the graph to write the piecewise function, okay? So what's the template that I use? What does it look like? If I want to just kind of fill out the write the template, and then we'll fill in the specifics. If we call this f of x, let's say, how do I write a piecewise function again? Okay, I have to do the open script bracket. And how many rows am I going to have? Yeah, 2, because there's 2 pieces. Good. So let's color code these, and let's say the first one's going to be red. How about? So this guy. I like to start with the domain. Okay, let me scoot this thing down a little bit. Let's see here. Let's do that so we can see it better. I like to start with the domain. So what's the domain of the red? No? Okay, so it's x is, in this case, x is going to be, how could I just want to say that with an inequality here. Less than, or, everybody agree? Right? The projection of that red graph onto the x-axis would just fill in the x-axis starting at 0 and going to the left forever, right, with a closed endpoint. So the domain is x is less than or equal to 0. Give me thumbs. Does that make sense? Okay, that's where the red function lives. Now, what is the red function? I mean, how could I come up with the equation of the red line? In general, like this is a pretty easy one, but what if I just gave you a random line? How are we going to write the equation of that line? What would we do? Well, eventually we want to write it in slope-intercept form, but I usually can't start there. In this case, I probably can, but if this were a harder problem, where that line were not so conveniently placed, what would I do? Okay, what is that? Y minus y1 equals m times the quantity x. Point slope, there we go. So we're going to start with point slope. So to be able to input, what are the ingredients of point slope formula? Point and a slope, right? So we would have to come up with the value of the slope and the coordinates of 1 point. And to get there, I probably just need to find 2 points, use those 2 points to calculate a slope, and then pick one of those as my point that I input into point slope form, right? This time it's pretty easy though. I mean, you can just look at that, and we'd say in math by inspection, meaning just by looking at it, I can determine m and b right away. What's m? 1. Looks like, doesn't it? If I pick any 2 points, it looks like the rise is 1 and the run is 1. And then you can see that that line goes through the y-axis at 0. So we know m is 1 and b is 0. So we know the equation of that line. What is it? Y equals x. There's the first piece. Okay, give me 1 to 5 on that. How are we doing? Okay, let's do the second piece. What's the domain of the blue piece? What's the domain of the blue piece here? Okay, that's the equation. What's the domain? X, okay, it has to be x, right? Because domain is the set of x values. X is greater than 0 because the x values are just starting at 0 and going towards positive infinity. It's an open endpoint though, so we don't include 0. And then what is the equation of a horizontal line with a y-intercept of 2? Y equals 2. So there it is. Okay? Make sense? Okay? I want to show you how to do this on Desmos. How to graph this on Desmos. So maybe you want to log in, and you can just go along with me here. Log into Desmos Graphing. Okay, here's how you do it. So if I have like a 3-piece piecewise function here, here's how we put this stuff into Desmos. So you use function notation. So we'll say f of x equals, and then the first thing you do is you're going to open up a set of script brackets, which makes sense. It kind of follows the way we would write this. So it's meant to closely align with the things we would write on a board. Helps you remember it. So script brackets, and then we're going to do the domain first. Okay. So for the first piece, we would just type x is less than or equal to -2. That gives us the domain of the first piece. To get the range or to get the graph that goes with that domain, we're going to put a colon, and that's the way of telling Desmos, okay, for this domain, x is less than or equal to 2. We graph the function y equals, and then I just put in a 2x. So there's the first piece. I'm going to do that for each of the 3 pieces, and I'm just going to separate the pieces with commas. So the next piece, you guys tell me, how am I going to do the middle piece? What do I do first? What do I do first for the middle piece? Same pattern. Is the question how to do that? Because it's the domain, right? In Desmos, this is really nice. In Desmos, you do it exactly like that. You just write that 3-part compound inequality exactly the way it looks. So we would just type it in as -2 first, then a less than symbol, then I put my x, and then less than 4, and then you got it, right? So you're going to put it in just the way it looks, colon, what comes next? -1 minus x, and there's piece number 2. Now what? How do I separate that from the third piece? Comma, then what? X is greater than or equal to 4. Okay, so how do you do a greater than or equal to in Desmos? Anybody know? You can't, there's a button for it, but again, like when you're doing lots of work on Desmos, which you'll do at some point as you move forward, It's better not to have to take your fingers off the keyboard as much as you can. Leave them on the keyboard. You can just type an inequality and then type the equal sign, and it'll merge them into a greater than or equal to. So x is greater than or equal to 4, and then what comes next? Colon, good. And then -3. And then last thing I do is just make sure, I mean, it already will be done. I'm just putting all this stuff inside the script brackets. But then if I, if I close the script brackets, it'll look just like this. Okay, that's what it looks like. Good, everybody get that? Okay, so make sure if yours didn't work, consult with your neighbor real quick. I want everybody to get to that point where they can get this thing graphed. Just that top line is all we're doing, right? So this is, that's what you should have. Okay, anybody tell me here? Be brave. We need a little more, two-way discussion here with this group. Be brave. What's a weakness of that graph? It doesn't look like the ones we do. There's something about it that's not as good. Say it again. We don't have the endpoints, right? And that's important because we don't know which are open endpoints and which are closed endpoints. That's one of the big weaknesses of using graphing technology. But there is a fix. There's a way on Desmos that you can determine which points get to, which intervals get to keep the endpoints. And here's what you do. I'm just going to start over with this. So we're going to create a new line, and we just want to create ordered pairs at the endpoints. So when I input a value of -2 for x, why do I pick -2? Well, because that's the boundary, right, between the pieces. If you want to, by the way, you can put those vertical lines in too. Okay, here's a way you could do that. Like my vertical lines that separate the pieces would be at what x values here? -2 and 4. So I could do x equals -2. Everybody see that? And then I can also do, like if I want to do x equals 4, I can just hit a comma and go x equals 4. Uh-oh. Why did that not? I think I've put it in script brackets. What the heck? Why did that not work? Here, I had it on there. I gotta look and see what I did. Oh, no, I didn't. Huh. Well, I can't remember how to do those all. We'll just do them separately. If I want to do x equals -2 and x equals 4, there are my vertical lines, but they look like they're part of the function. So to make, if I want it, you don't have to do this, it's kind of optional, but moving forward, this is kind of a handy thing to be able to do. By clicking that little gear up there, I can change the way those look. Like I'm going to make those both black, and I'm going to make them dashed lines, and I want to make them real light. So I can go down here to that, everybody see that line thickness? Instead of being 2.5, that's kind of the normal, I'm going to go like 0.5. Or even just like 1. I think 1's pretty good, like 1. And then it gives me light lines like that, so I can see the vertical lines, okay? But that still didn't solve the problem. I want to know where the endpoints are. So all I have to do is go down and add those endpoints. I'm going to graph those as ordered pairs. When you want to graph an ordered pair, I want everybody to close those down for just a second, or at least just look up here. When I want to graph an ordered pair in Desmos, to graph a point, I just write an ordered pair. Like if I want to graph a point at x equals 2, y equals -6, I just type -2, 6 inside parentheses, and sorry, I want to do 2, -6, so we can see it. There it is, right? And if I hit label, it gives me the coordinates. Everybody see that? Okay, I want the endpoints to be attached to these pieces though. Any ideas how I could do that? Do I have to go through and calculate what those coordinates are going to be? Like figuring out which piece I plug it into? I could, right? Like for example, if I want to put an endpoint at -2, which piece does that get attached to? Does it get attached to the top piece or the middle piece? Okay, so then I would end up plugging -2 into the top and get x equals -2, y equals -4. Everybody agree? Okay. So I could do it that way. I could figure it out. -2, -4. And it puts the endpoint there, and I can see it gets attached to that piece. But I don't even have to do that. In Desmos, I can just let Desmos use that function notation to figure out for itself what the y value is going to be. I can just type in the ordered pair -2 and then comma, and for my y value, I'm just going to do f of -2. And look what it does. It figures it out for me. It knows it's supposed to go there. It uses function notation. So how am I going to get the other ordered pair? What am I going to do? Oh, you mean +4? Yeah, right, because we're going to pick this x value. Good, that's it, exactly. So I'm going to put a comma and make another set of ordered pairs, and I'll do 4, comma, f of 4. And look what it does. It puts it right there. Now that, and I can even make these red, just to make it, you don't have to, but there, now we can see they're attached to our piecewise function. Okay, that fixes things, because that tells me where the closed endpoints go. So every other endpoint has to be an open endpoint. Okay, everybody get that? So that's kind of an important thing to do too. When you're writing these piecewise functions in Desmos, when you're entering them, include the endpoints. Once you've defined f of x, include those endpoints, and then you can visually just see exactly what's closed and what's open. Okay, give me 1 to 5 on that. Everybody get that? What I just did? I'm going fast. Okay. All right, let me take a picture of that for our notes. And in the notes, I left you a link to a pre-built Desmos sheet if you want to use that. Okay, oh, there it is. Okay, I guess I already had it in there. Okay, why don't you guys do one of these? Do one of these. Graph this on, how about just graph it on Desmos? Take a second and everybody graph that on Desmos. I just want to see everybody's getting this. Okay.